Welcome to the Really Likable Geeks podcast. I'm Steve.
I'm Matt.
And I'm Stuart.
And this is the podcast where we talk about nerd stuff and things that keep you from going outside, like video games, comic books, and other nerd things alike. Yeah. I cut that really short, and that's okay.
Yeah. They know what nerd things are.
Every week it's a little bit
It's
different,
always something
Steve. It's all right.
I haven't said board games in a while.
I know.
You make some variety.
I do.
Well, in April, we'll talk about nothing but board games.
So this week, for Book of the Week,
Ooh.
Nice.
we're reading Poet Anderson's of Nightmares. It's the second installment of the Poet Anderson series. It's by Tom DeLonge from Blink-182, Angels and Airwaves.
Really?
With Suzanne
He's
Young.
an author.
Huh?
He's an author.
Yeah, Poet Anderson.
Learn
it's,
something new every day.
Yeah, it's awesome. It's really, really good. So I'm going to read the synopsis for you guys really quick here so you guys can get a basis for what it is. It's not that it's a really complicated story, but it's better if you just read the synopsis I've learned. So
Hit me.
Sure. I'm listening.
so here's the synopsis of Poet Anderson's of Nightmares. So Jonas Anderson and his older brother Alan are lucid dreamers. But after a car accident lands Alan in a coma, Jonas sets out into the dream world in an attempt to find his brother and wake him up. What he discovers instead is an entire shared consciousness where fear comes to life as a snarling beast called a night terror. We all have night terrors, so we know what those are. So that's like the monster. And a creature named Rem is bent on destruction and misery, devouring souls of the strongest dreamers. With the help of a dreamwalker, a guardian of the dreamscape, Jonas must face his fears, save his brother, and become who he was always meant to be, which is Poet Anderson.
This sounds like, not knowing anything about the book, it sounds like a fantasy version of Nightmare on Elm Street, and I like that.
It's really good.
So that's actually really cool. I didn't know you could write.
And see, I thought
It's amazing.
my mind went in a different direction. I went, this sounds like a significantly less LSD version of Psychonauts.
There you go. Fair
It's
enough.
basically it's like a supernatural romance book. It's incredible.
I like that cover art too.
Yeah, it's really, really rad. It's super cool. You want to check it out?
Yeah.
It's really cool. That's the second installment. The first one is just Poet Anderson. And he has a few books. It's To the Stars.
Cover art.
I think it's To the Stars is what it is. It's his actual like publishing thing that he has or whatever.
Cool.
But yeah, Suzanne Young, she's amazing as well. So
Tom DeLonge.
Tom DeLonge.
Talented musician and writer.
I'm pretty sure you can pick it up at all major bookstores. I got that one from Billy from Hardest.
Cool.
He's allowed me to borrow it, but you can get it from the To the Stars
Yeah.
website. I think it's like I don't know. I think it's like $10 or something. It's relatively on the cheap side, but it's a good read. It's a really, really good read.
Cool.
So check it out. Poet Anderson of Nightmares. And yeah, that's our book of the week. Hand this back over here. Okay, that works.
I actually
Marcus
like
Phoenix
it. Yeah, I like it right there.
Marcus Phoenix is reading really intently.
Yeah, he's super into that.
I've been waiting for this.
My life has led up to this moment.
Yeah, by the way, we moved the set. We added some set pieces in.
Yeah,
And,
we have more room now.
Yeah, I can't punch anybody too far away.
We'll get a poke and stick.
All right, fair enough.
All right,
That's how we turn
We'll
everything.
give you a reason to use it, too.
That's how we turn
Yeah.
everything on and off.
we'll get a poke and stick.
So Matt, what are we talking about this week?
Well, this week we are going to talk about a little bit more in depth of what we already talk about, because we always bring up a lot of science fiction in our podcast. We love Star Wars. I mean, we all love Star Wars, but we talked about Star Trek a while ago. We've mentioned quite a few science fiction type things. We're going to talk about the science of the science fiction. We're going to talk about like where we are right now in terms of our scientific advancement and kind of how that correlates and corresponds to where we are in science fiction. I know Stuart mentioned not too long ago on one of the podcasts, and I forget which author, I'm really sorry about this, but he had so many ideas
Unacceptable.
for the internet, and so many were right, but also so many were wrong.
It was Neuromancer's author.
Yeah,
There we go.
Gibson.
Yeah, and that was just
we talked about that a few times.
from that
It's a very good
time
book.
period from further back. Well, now we're going to jump it to where the time period's now, science fiction being written now. How close are we to the actual, is it fiction?
Mm-hmm. Yeah, where's the line between science fact and science fiction?
Right.
So I guess
How close are we getting to those advancements in
so
science fiction? It's
I guess
crazy.
we'll preface this with I think the major thing the major story, at least in science.
Over the past
Science.
I love science.
Science.
I do. I love science.
What's new?
There's always something new in science.
Yeah, but
Always.
I think the major, I think it's just been dominating this past year, and it will continue this year. Was
Trappist 1?
Trappist 1, which is the discovery of
the new solar
the
system.
new system. It's in
relatively close and habitable.
Yeah, it's in Aquarius. It's 39 light years away, give or take, or 12 parsecs, if you want to do it like that.
Yeah. We can all relate on that one.
Yeah, it's 12 parsecs. So it is classified as an ultra cool star, which is an actual star.
It's a dwarf star, isn't it?
It's ultra cool.
Yeah. It's an
well,
ultra cool
yeah,
dwarf star.
it's like a subclass.
Yeah.
Meaning that its temperature is
It's
significantly lower.
It's
a little
also
bigger.
smaller.
Yes.
Our
No,
star,
I
our
thought
current,
it was bigger.
We're
No,
a class
our
M.
current star is 12 times larger.
Yeah.
Than Trappist.
We have a class M star.
Yeah.
Oh,
so
okay.
Trappist is actually relatively the size of Jupiter. Like, as far as we can tell, Jupiter might actually be bigger than the Trappist star.
Oh.
But because of its temperature, planets that are a lot closer to it, like
They're in the
like
habitable
Venus
zone.
and Mercury, would normally just be scorching wastelands for us in our solar system.
Yeah, relative distance. If Earth was the relative distance that we are from our star to the Trappist, it would be
frozen.
We'd be uninhabitable
Okay.
because it's a lot cooler of a star. It's smaller. So, yeah, ultra cool star, which I just thought was an awesome classification for stars.
Because it's ultra cool.
Yeah.
So the
Super
habitable,
cool. Sorry.
what they call the habitable zone, which is basically an imaginary ring around the star where theoretically life could exist because the temperature isn't too high or too low, is a lot closer than ours is because of the size of the star. It was initially discovered by Trappist, which stands for the Transiting Planets and Planetesimals Small Telescope. So that wasn't too much of a stretch on naming that one. But they all, and the reason why we stopped looking at M-class stars that are our size, and we started looking at smaller stars, was because of the length of orbits. So with a smaller star with planets surrounding it, we can detect habitable zones easier than with bigger stars, because a bigger star, you'd have to wait longer for the planets to orbit it to get an idea of like its relative movement.
Right, because you have that imaginary ring, and you have a planet that's in that imaginary ring, and it's all good for 6 months, and then it slides out of that imaginary ring, and you realize its orbit is more elliptical, and suddenly that planet's not habitable.
Yeah,
because
exactly.
even if you were on it and everything was going good, 6 months later you're all gonna fry.
Exactly. So we started looking at smaller stars just so we could get a better read on their orbits and how they work. So most of the planets that are in what we think are the habitable zone of Trappist, their orbits are only about a week to orbit the star.
Whoa.
Really?
Yeah, that's how close it is.
Wow.
Yeah.
That's really close.
Yeah. Well, it just shows you like the comparable masses of
That's
our star to
mind-blowing.
Trappist. Yeah, I know, it's cool.
Those planets have to be like the size of the surface area of a planet would have to be the size of a country here.
No, some of the relative size of the planets we're estimating are about Earth or Venus, or Earth or Mercury.
Well, Mercury, I mean, if you took surface area of Mercury, it's probably nothing compared to us on Earth.
If you want to be able to like put it into like a number, like the axis of it is like 1.66 million kilometers. That's about it.
Yeah.
That's about the whole like radius
From
of it.
pole to pole.
Yeah. But like some of the companions, like for example right here is 6.7 million kilometers.
Yeah,
So-
that's more like us.
Yeah. And then there's one that's unknown that's 9.4 million, which is freaking huge. Yeah.
I think that's more like Neptune size.
Yeah. So like they have some frames of reference. See, like Earth's orbital period is 365 days
Right.
to orbit. Trappist 1 is orbital period is 1.5 days. Yeah.
A year is a day and a half.
Yeah. Yeah. The distance is 0.11. 1.9 is the radius. Yeah, it's
All right,
It's
so,
insane.
So here's an
because
interesting.
Venus takes 224 days.
Here's an interesting, just
Think
random
of that
thought.
about that.
If we did have the technology and we went there and we lived there or colonized that planet, what would we classify as a year?
Well, okay. We couldn't classify days because here's why.
Because
Because it orbits in one.
No, because the days are measured by planet rotation.
orbit.
Right.
Years are measured by orbit around a star.
The whole star.
Yeah.
Because of how close the planets are to the star, they're tidally locked.
Oh, they're like our moon.
Oh,
Their
okay.
rotation is locked.
Yeah.
So
They're
we
rota-
think
yeah.
and this is all, obviously this is all just best guesses, but there should be dark sides of the planet.
So a day in the year is the exact same thing.
Yes, so you're going to have a side of the planet that's always
And it only has
Always
one
light.
sun, right?
yeah,
Yeah,
that
that's
we've
one
that
binary
we've seen.
system.
Okay.
That we've seen.
Yeah.
So
What's that? It's called tidal locking, right?
yeah, it's
Yes.
tidal lock.
So,
So-
and does it have? And then what's the tidal heating
yes.
as well? So
That's actually, I've read, very common among satellites like moons. Tidal locked moons are very, very common.
I think it's higher than the Earth's, isn't it? It's higher than the Earth's heat flux. If it would have then, right? It'd be way higher than ours, right?
It's hard to tell because we don't have any relative data for how an ultra cool star would burn through an atmosphere.
Yeah, there's nothing to compare
That's
it
even
to.
saying that those planets have atmospheres, right?
That's assuming
Because
we haven't
that's all like extreme X-ray and UV radiation, right?
Yep.
Yeah, so
Yeah.
we're just at this point it's our best guess. The other reason why we're looking more at ultra cool stars is because they're the most prevalent star in the galaxy. There's more ultra cool stars that we've seen than M-class stars like our own.
Right.
So it also has to do with we're trying to find planets that are similar to Earth in size and relative makeup because of gravitational means. Like if you have the bigger the planet, obviously the bigger the gravitational pull.
Yeah.
Yeah.
So you're going to be heavier on a bigger planet. You're going to be lighter on a smaller planet. We've seen like with our astronauts who landed on the moon, smaller mass in space. Smaller gravitational
And
pull.
even to an extent, Mars, our rovers on Mars only weigh, I think it's 70% of what they do on Earth.
Something like that. Yeah.
Yeah.
Yeah, so a lot of this is guesswork because we have no idea like what the ecological like issues would be for a planet that's tidally locked with an only day side and an only dark side.
It would mess. Oh my gosh, I couldn't imagine like inhabiting that. It'd be so messed up.
I would imagine
imagine
you would have to
Move
like
to
live.
Alaska. That's the closest
fair.
you could
That's
get.
the closest you can get. Yeah.
I would imagine that you would have to, depending on like how solar radiation would play after being filtered through the atmosphere, I would imagine there would be a habitable ring near the dark and light
Yeah,
border
there'd be a temperate zone.
where like the exact like center of where the sun shone would probably be I don't know, maybe too hot.
Yeah.
But then again, this is all guessing because we only have
It's all theoretical. It's all we have to go
we
off of
only
right now.
we only really have data on like this is how our star affects us because we have this kind of atmosphere
our
and
orbit
it
and
filters.
everything as well.
That's assuming that any of those planets, A, have atmospheres, and B, those atmospheres are nitrogen, oxygen rich.
So I looked up a diagram that for how like how the orbits are in relation to ours. So Jupiter and its major moons. So it has like Europa
Yeah,
and
Titan.
Callisto and what's that one? Ganymede or whatever it is. It's got 4.
Fun fact
Yeah.
is Jupiter, which was the Roman god, all of its moons are named after the many lovers of the Roman god,
is that-
Jupiter. And
Oh.
the probe that we just sent to Jupiter to observe it is named Juno, which is
Oh,
the wife
yeah.
of Jupiter. So we're literally sending a satellite
I never
to go check on its husband. Yeah,
I
that
never
was
made them
space
connection.
jokes.
So yeah, so it's got like Europa, Ganymede, and Callisto. They're really close together. So Trappist 1 has basically how our solar system is you have the inner solar system,
Right.
and then you have Mercury, Venus, us,
Does
and
it,
then way out on the edge
does
you
it
have
show
Mars.
Trappist 1 as having an asteroid belt?
I don't
As
think
like
so.
as like how we have a Kuiper belt.
Well, because we have an asteroid belt.
Yeah, because
Yes, I don't know if they've done
Not
that.
all systems do. I was
Yeah.
just curious.
they've
So-
been This is why they've been focusing on smaller stars because we can observe the orbits
quicker. We get
quicker.
faster results.
Yeah, exactly.
So we have the inside of our solar system is like
From Mercury to Mars.
is Mercury to Mars. So Mars, Mars is pretty far out.
Yeah.
In comparison to like how close Venus
They're
is and Mercury and
further
everything.
from us than we are from Venus.
So the distance to Mars is the distance of Trappist 1's furthest planet. And inside, from that point inside, there's 6 planets.
Wait.
On the inside,
So
as close proximity as the moons from Jupiter on Jupiter.
So
that's why
the
it goes so
distance
quick.
from Mars to our sun or Mars to us
Mars to our
sun.
to our sun.
is the furthest planet from Trappist.
Yes,
Okay.
but in
It's
between,
really
and then there's
close.
6 other
6
planets.
other ones,
It
and
has-
the radius is about as like the first 3 to 4 planets are about as far apart as the 4 moons on Jupiter.
It has to do with
Which is
gravitational
close. That's
pull.
really
because
close.
our star is 12 times larger than
Right.
Trappist.
And it can catch
So it can
more
catch,
extra
yeah,
solar.
exactly. It can
from
catch
further.
a lot further out.
Here's
stuff.
an interesting thought. I don't actually know. You might be able to look it up. Mercury, I think I do know. Mercury's orbit is 92 days.
Mhm.
Mercury is very close to our sun, and its orbit is 92 days.
It's the hottest planet, right?
It is.
Yeah.
It's a scorching ball of death. But
Let's
So-
go there.
Trappist's closest planet, Stuart just read, was 1.5 days
to what?
To
Orbit?
orbit.
to orbit.
To orbit
For
the sun.
Trappist
Yeah.
or
For the
Mercury?
closest-
closest
thing.
planet.
Yeah.
Mercury is very, very close to our sun.
Yes.
Relatively speaking, and its orbit is 92 days. This is 1.5. I mean, that practically seems like you could just reach out of the atmosphere and touch the sun.
we've been observing. Well, that's the other thing is why this system is so important is because we're observing like solar radiation flares breaking through the atmosphere of that closest planet,
Yeah.
which we've only guessed at like what would happen if a solar flare like reached out and touched us, like how terrible that would be.
Catastrophic
Yeah,
to everything
burning
it would
death
be.
for
Yeah.
everyone.
Yeah.
So
let's see
we're getting a
here.
lot of really cool data on it.
Let's see, I have all of the actual like data for each planet that they have in Trappist. So Trappist 1, the big one, the main one, the mass of it is 0.85, which that's huge.
0.85 to us, yes?
Yes.
Yeah,
I don't
we
know what that
use
sound was.
we use Earth
But
as
okay.
a relative measurement.
And then like its orbital period by days. So the first planet, the big orange one, is 1.5.
Yeah.
Full orbit. And then the furthest one, which is like the unknown one, the one that's just
Right.
way out there in the boonies, is 18 days.
So
That's
the
it.
ones that we
That's
think
Still a faster orbit than Mercury.
Each planet,
Well,
like the
it's-
second planet is 2, 4,
it's
6,
a relative
9, 12,
speed, you know
18.
what I mean? Because of the
That's true.
size of the star. So the ones that we actually think are in the habitable zone have about a week-long orbit.
Right.
But all inclination for it is like 89. It's like
Yeah.
89.65, roughly. So it's crazy. I couldn't imagine.
Yeah, so we have
That's crazy.
every telescope and satellite that's got, a telescope on it
How
is
long-
pointed over there.
How long do you think? Have we sent a probe?
We haven't because it would take too long, but the Hubble's pointed at it now.
Yeah.
So the Hubble will be able to give
That's
us.
crazy to me that we have technology that can see that far.
Yeah.
That's insane.
yeah.
Well, now here's the other thing.
It's not light years away.
It is.
It
or
is.
how many light years away is it? I can't remember
30,
what we said.
30
It's like 40, basically.
Yeah, 30. It's 12 parsecs, so whatever that. I don't remember. It is 39. 12 parsecs is about 39.
Just
light
assume
years.
that what we're looking at is 40 years old.
Yeah, that's the other thing.
Oh,
is
yeah,
that-
12.1 from the sun.
Yeah, so
Constellation Aquarius.
hopefully it's still there. Well, yeah, we'll
yeah,
know
like
in
what
40
kind of
years.
information are we seeing? Like how far? Like 'cause
40
We
years.
haven't
Yeah.
haven't seen like clouds or anything that would tell us that there is an actual atmosphere on any of the planets.
Or even water.
But we've just started observing
Yes.
it. Like every major telescope, the one in London,
Data's
the
not going to happen
the
instantly.
Cursed, the Russian one, the Hubble, like
the Russian one.
I don't know how to say it. It's Cursed, I believe. I forget the name.
Yeah,
of
it is.
KURST?
Is it
I think
Cursed?
it's cursed.
Yeah.
Okay.
Or cursed or something.
So
So how would we get to these? How do you think we're gonna be able to get there if we ever do decide to have that we ever get advancements in technology to have something
I mean,
that
assuming
could get us there
assuming
without
where-
just taking a rocket and be like, all right, see you in 400 years. Like,
assuming
or
where
whatever.
we are right now, if we could somehow achieve it, we might be able to reach speed of light at some point in the future. But even then, you're looking at 40 years at speed of light.
Yeah.
That's plus the time it takes. We'd have to somehow exceed the speed of light.
What's
which,
that? What's that thing that they're
which
building
breaks
that
physics.
they've been talking about?
Mhm.
We wouldn't be able to, like, physics says we can't break the speed of light. We'd have to do that somehow.
Speaking
can
of
bend it.
speaking of breaking laws of physics, the Eagle Works laboratory, which is NASA's physics and propulsion laboratory, just recently started doing vacuum testing, and the results got leaked of their EmDrive. So the EmDrive,
the
Which-
mass relay.
Breaks the laws of physics.
yeah, the mass relay.
Yeah.
The EmDrive
All right,
was
fill me in. I know nothing about this.
okay. So the
It's mass
EmDrive,
relay. It's what it is.
the EmDrive was something that was originally conceptualized.
EmDrive stands for electromagnetic drive.
Yes,
Okay.
Specifically.
it was.
All right.
You can base a
Electromagnetic.
lot off of just that.
Yeah.
Yeah. It was originally conceptualized and it was kind of written off as like not possible because the basis for it would break Newton's third
Third
law.
law.
Well, yeah.
which
I mean,
is
we have
every,
electromagnetic trains that you don't see them in space.
exactly, because every action must have an equal and opposite reaction.
The amount of force you have is the amount of force you're going to get.
exactly.
Okay.
The EmDrive works without any fuel or propellant. So it doesn't burn anything.
So do electromagnetic trains and such.
Yeah. It's just a giant slingshot, essentially.
Yeah, but the difference between a mag rail train and this is that it's not propelled by switching polarities of magnets. Like a mag train
Right.
is switching polarities of magnets.
And it's
So
just,
it is pushing
but
magnetics.
You're not. It's not a fuel.
No.
It isn't a fuel,
Well-
but it doesn't break. But the mag train doesn't break
Exactly.
the third
and that's
Newton's
where
third
I'm
law.
getting. You don't
The
see those in space
EmDrive
because
does.
You're only getting however much power the magnets are able to produce.
Exactly. So
So
the
this
difference
is able to produce more power than it should.
it shouldn't do anything.
Think of like a bullet train.
think of
But like with
think of a
gnarly
rocket.
magnets.
Okay.
Well, just put it back to propulsion.
I'm picturing a rocket.
Think of a rocket. A rocket burns propellant or fuel, and it expels the burning propellant through the back of the engine.
right.
So you have a force being
Ejected,
pointed this way, so
which
you go this
gives
way
you the force you need to go the
to
other
give
way.
you thrust.
You said thrust.
Yeah, I did say thrust. It was bound to happen.
joke.
Space thrust.
Space thrust.
so-
Is that what you said?
A normal engine is shaped like a cone
Right.
with the wide end where the propellant is
And
expelled
they
from.
usually got like 3 or 4 of them.
Exactly. The difference between the EmDrive is that it uses microwave photons, and they bounce around inside of this cone chamber, and they are pushed out. Well, not pushed technically because there's no propellant. They're expelled through the pointy end of the cone,
So
and that gives
after
you
bouncing
thrust.
around, they hit each other, and eventually they come out.
Yes, and that propels it forward. The problem
Shooting
is
an electron
yes,
out of the pointy end of a cone.
Yes. creates thrust.
And it's not even guaranteed because you're just kind of bouncing them around after giving them microwave radiation and hoping that they eventually go out that end.
No, because it follows a funnel law.
But there's
It's the same idea of like how
Sorry.
it's funneled into a tighter spectrum, so that's why it's
it's going to
forced up.
have to go that way,
Yes.
but it's not.
yes.
Science is hard.
There's nothing.
No,
that's-
the more you have in there, the more thrust is going to come out.
Gotcha.
You said thrust again.
It's exponential. Yeah.
Okay, but now here, how
The
do
problem
you,
is that it doesn't actually burn anything.
right? But there's
So
here's
it's
my
like-
question. You
it-
can run out of them, can't you?
No, because it's
It's like infinite. It's
yeah,
just like,
it's based on electrical energy.
Yeah.
You can power it with solar panels.
But they're electrons,
Your
Yes.
which are on atoms.
Yes.
If you're expelling the atoms through the funnel, which
Mhm.
not by a fuel or anything,
Mhm.
you will eventually run out of atoms in that cone to funnel.
No, because of conservation of mass.
Where are you getting more atoms?
There is an infinite number.
But the
Throughout.
deeper you go into space, the less atoms there are per space.
No, solar radiation is everywhere. It's permeated throughout the entire galaxy. Here's the other thing: is you're taking
one atom per like 9 square meters.
No, but you're taking solar radiation and you're charging a battery with it. So the energy is held in a battery and then used to power the EmDrive.
This is blowing my mind right now. I can't wrap my head around this.
Space is hard.
Yeah.
I can't wrap my head around this.
So like the normal
I'm just watching the whole time, just like, whoa.
I can't wrap my head around this.
This is the problem.
It
is
doesn't
it
make
breaks?
sense.
It doesn't, but it works. We don't know why it works, but it does.
Look, it'll either work or kill us all.
No, it does though. We've tested it. It works.
Either we'll do it right and it'll work, or it'll kill us all.
We don't know why it works. So there's a bunch of theories because
Dude, there's so many things when it comes to science and space and all that stuff like that. We have no clue.
Science.
We
have
don't know why.
clue, but it just
Magnets.
does. And we're like,
how do they work?
All right, cool.
We still don't really
it's
have
only a
an
matter
answer.
of time before a scientist gets to a point where they're like, "What's this do?" And then we just get sucked
No,
into a
but that
black
was-
hole.
that was
To be
basically-
entirely fair to your point,
Don't
gravity.
push the button. I want to push it. We're
Gravity,
dead.
while yes, we call a law of physics, and we're 99.9999 with a ton of nines at the end of it % sure, is still technically speaking a theory.
It's all theoretical.
Yeah.
Yeah.
That's why we still have a thing called theoretical physics.
So there.
Theoretical physics makes this kind of stuff
Yeah.
because it breaks the laws of real physics.
Okay, I'm actually going to read this directly from the Finnish paper
Okay.
because there's one
Finished
team
as in finished or finished
No,
as in like from
Finland,
Finland?
from
Okay.
Finland because a team in Finland proposed
Finland.
a team in Finland proposed how the EmDrive could work and actually function without breaking Newton's third law. So by propelling photons as a type of exhaust, that's how it works.
Okay, so now we're at photons, not electrons.
Yeah. Well,
Okay.
yeah.
Because
Every time I hear photon, I just think like fire photon cannons. Like,
well, photon. But the thing is, photons function both as a wave and as a particle.
yes,
Yeah, that's true.
and a stream, doesn't it? It can be function as like a streamline, can it?
I think that's never been proven.
Okay,
I think that's the wave you're thinking of.
yeah,
They function both like light
but
and
that's
like a particle.
that's streamline, I would say.
Well,
But
a
I
lot
don't
of
know.
people, a lot of people are calling BS. A lot of like science people, a lot of science people. No, a lot of research facilities are calling BS because they're hearkening it to like the faster than light neutrino that we observed.
Oh yeah.
But
I
it
know
was
what you're talking
actually
about.
it was a faulty experiment because of thermal, like a latent thermal radiation.
Yeah.
So it gave a false positive.
Yeah. Which
But-
with like, you know, with that kind of stuff that it's gonna happen, but they definitely jumped the gun with being like,
They did.
Look
and,
at- whoa,
and that's
it
why
works. They-
and
no.
that's why this is all based on leaked data. NASA has not officially confirmed anything. They're like, we're still testing. We still need to do a lot more testing. The other interesting thing was that another idea of how it could not be breaking Newton's third law, but still providing thrust, is that
you said thrust again.
dude, I'm gonna keep saying it. We're talking about engines. Thrust.
You said it again.
I hate
Space
you
Joe.
I hate you so much right
All
now.
right. I'm still trying to wrap my head around this, so go for it.
Okay, so imagine on
We're not
well,
breaking
wait, hold
Newton's
on.
third law.
I'm
Yes.
sorry. Were you continuing off the paper that you were reading?
Not yet.
this is another theory of
Okay,
how
start of the paper.
this is another theory.
Okay.
So they have a lot of people are throwing out theories on how it could work
Without
without
breaking,
breaking
the laws of physics.
our known laws of physics.
Okay.
So
Which may or may not be right.
yeah, I mean,
Does-
it could just be that Newton's third law needs like an addendum,
Right.
like except for things on the quantum level.
Yeah.
An object
So-
in motion tends to stay in motion.
Unless it doesn't. Until it
acted on
doesn't.
by an outside
Yeah,
force.
exactly. It might be one of those things.
Yeah.
So the other major theory, it came out of, I think, Edinburgh, their research team, was that on the quantum level, there are particles that are constantly and without being observable, phasing in and out of our dimension of reality. So basically, they're saying there's a multi-layered dimensions of reality, and we have these tiny quantum particles that are just phasing in and out of it at will, just as they do. This is all theoretical because no
Okay.
one can prove this.
Very much so.
And that,
Because you had different dimensions, and I'm like, all right,
yeah.
there we go.
and that is what the photons being expelled out of the EmDrive are pushing against.
The other dimension.
Yes.
So what you're telling me,
Blowing your mind again.
what you're telling me is that we are pushing away the other dimension to give us the force we need to move this way.
Essentially.
Kind of?
Yeah. You're on the right track.
Yes,
So
you're on the right track.
I'm opening my front door,
Uh-huh.
and I am pushing on my screen,
Yep.
and my house is starting to move up the street.
And see, that's the problem is like people
You know, like
keep-
how ragdoll physics in video games work, where like you can punch someone forward, but then get thrown backwards. You know, one of those.
and that was a lot of the
you ever
people
play Gang Beasts? Perfect example of everything.
a lot of the people who were saying that the EmDrive wasn't possible, the example that they came up with was, okay, you're in a spaceship and you're in a vacuum and you push up against an outer wall and it goes in that direction or it goes in the opposite direction.
So I can punch the back of my spaceship, and it will go forward.
Yeah.
Yes.
That's what they're saying. They're like, that's why the EmDrive isn't possible because of that. Because that's the
It's
basis.
like reverse propulsion. It's essentially is
yeah.
what it is.
They're, which
Like,
obviously
you know, like
can't.
So
It's
if
like
I
a-
think hard enough that I'm gonna go this way,
Yeah. You're
gonna
it'll
go-
actually send me the other
Yeah,
way.
it's like a push-pull
Yeah,
method.
so the-
push pull method. Yeah.
So basically, the two main theories are
sorry, yeah, you're just
either other dimensions.
blew your own mind.
Well, and
I mean, it is pretty
Okay.
incredible.
and we can.
I am willing so far to accept the fact that we have just broken Newton's third law and we need to rewrite it before I am willing to accept the fact that there are multiple dimensions and I'm going to kick my screen door to move my house up the street.
Well, no, because we've always something that's been so big in science fiction about faster than light travel. There's a warp drive. Which how does a warp drive work?
I don't actually know.
Oh, okay.
Teach me.
No, go ahead and give him the spiel about warp drive. I mean, you've watched like how Star Wars. You watched Star Wars.
Well, that's
Yeah,
a
of
warp
course.
drive is
Stuff
Star
like that.
Trek.
Which is why I don't know, because my knowledge of Star Trek is nothing compared to
So
Star
you
Wars.
you have a warp drive, which is basically like you propel it faster than the speed of light.
Yeah.
Like they have the dilithium crystals, which
so
are
basically, it's like a rocket, and you're shooting jet fuel
Yes.
faster than the speed of light.
you go. Yeah, you just keep going fast,
Yes.
and
Yeah.
you go faster and faster.
Okay.
In Star Wars, you have light speed jumps,
Yes.
which for a certain period of time you move at the speed of light, and you have to calculate your route so you
So
don't.
you know when to drop out,
okay.
Well, also so
You
you,
know-
don't
do you
like
know
pass
what- okay,
through
run into a star.
do you know
or
what
anything else.
Yeah.
Do you know what general relativity is? Like mass relativity and like special relativity, how that works is when you have energy and mass. So energy,
Yes.
mass, and then they're interchangeable.
Okay.
That's exactly what it is. So that's impossible. It's completely impossible.
They said the EmDrive was
With our
impossible.
current
Yeah.
laws of physics.
Yeah.
Yes. it
with
is
our
completely
current
impossible.
technology and knowledge.
Okay.
Yes.
Because think about the amount of photons, for example, that would require it. The actual like amount of that would require for it to be for energy and mass to be interchangeable is like impossible.
Well,
It's
they're saying
way too
they're
much.
saying it works like a funnel. So
And that's for that's material objects that weigh more than photons.
think of like
It's impossible.
think of like an actual like funnel,
Mhm.
and then BBs, and you just have BBs constantly filling the funnel and being siphoned and narrowed out to the point, and you get a straight stream through it.
So you have an infinite supply of BBs.
Here, let me read this.
Well,
Well, it's a
sent to the funnel.
finite. Well, it's a finite amount, but as you're moving, it fills it. You're passing through, and it's filling it with more.
I'm gonna read this for you. Matt.
So that EmDrive,
I'm
as
not gonna
far as
read
that
this then.
theory is
I'm just
concerned,
gonna go
I'm really sorry.
just
I'm really
stand over
sorry
here
because I'm
and-
still trying to wrap my head around this.
I can explain it to you. I found
So
something. that would
intergalactic
help
space,
you out.
Mhm.
where there's like, I believe it's one atom in every 39 something square yards. You will
But if you're moving
If
close
you're-
to the, but if
if
you're
you're
moving
already-
close to the speed of
if
light,
you're already moving at that speed, I think you're safe. But if you end up stopping in intergalactic space, you won't pick up more fuel.
Well,
So
here's
you
the thing.
can't stop in deep space.
well, here's the thing: is even in science fiction like Star Wars and Star Trek, they had ion thrusters, and ion thrusters burn plasma to maneuver.
Right.
Like Star Trek starships have ion thrusters,
Right.
and that's how they maneuver. But their warp drive and their engines, which they get their speed out of,
Yes.
is based on dilithium crystals and that, fictional thing.
And then all you
So
have
I'm
to
not
do,
saying you wouldn't need some kind of propellant based fuel system to like power spaceships, because you're always going to need that for maneuverability and
Right.
to
Minor
change
adjustments.
change your axis and yaw and so on. But getting up and going like a long distance,
And then if you just
This
need a
could
refill,
be-
you swing by the outer planet of any star
you just
system.
go, you just
And you
fly
just-
close enough to a star and you pick up the
It's
energy needed.
the slingshot effect
Yeah.
is what it is.
Yeah.
Which, like the slingshot effect, we've actually explored that, like in real life, like in theoretical physics, the slingshot effect. It's hypothetically it's possible to slingshot like
And-
around like
And we can bring this back to science
like,
fiction.
okay,
That was,
you know what the
Farscape.
event horizon is, right?
Yeah.
Like it's
Of a black hole.
yeah, it's actually theoretically possible to slingshot around that, like out of that, like because
Once you're caught in it, you're screwed. But
Yeah.
if you get close enough to it by slingshotting around, it gives you the extra boost you need.
exactly, because of the amount of like gravitation that's happening,
Right.
It's theoretically possible.
Well, we do it now. That's how we get out of orbit. If you ever watch any launch, no one ever launches a rocket straight up because the Earth is spinning.
relatively up.
Yeah, because the Earth is spinning, they launch it towards the spin and catch less atmosphere. So that when you breach the final layers of the atmosphere, you're not going straight out of it. You're coming at an angle, and you're already in orbit. You use less fuel that way.
Anyways, I was gonna just really quick back to we were talking about the different science fiction means of like intergalactic travel. There's
Well,
the
we're
Star
talking about the EmDrive. Yeah.
there's Star Wars and Star Trek, which you just go fast.
Yes.
But then another like big one in science fiction is a kind of null space or hyperspace or Z space. It's called a lot of different things, but it's basically where you phase out of our dimension
phase crystals charge.
and you move a relatively less distance and you pop back into our galaxy in a different area. So think like Event Horizon.
It's not time travel.
The movie Event Horizon.
No. When you said this, I don't know if you've seen the movie Hitchhiker's Guide to the Galaxy.
Yeah, a long time ago.
They have the improbability drive,
Mhm.
and the way they picture it and they give you a description is it clears up all the tedious mucking about in hyperspace, and it has the word hyperspace written as if it was a maze, and you see a ship go in and get stuck and moving around. They can't go anywhere. The improbability drive, it goes into the lower leg of the H, a door opens, it goes into the door, and then a door opens on the other side, and you're out.
Yeah.
That's essentially a wormhole, is how it is.
Yeah.
Theoretically saying you could enter from one side of the universe and enter the other side just by entering like a black hole.
Wormholes.
essentially.
Well, okay, but
But we don't know what happens
in
when you're
theory-
inside of a black hole.
In
but-
theory, wormholes exist.
yeah. All it is
uh,
just like the best way you could explain it is to take a piece of paper, bend it in half.
Yeah,
The point from this point to this point passing through
Yeah.
would be how a wormhole would work.
Mhm.
That's the best way you can explain it. But
with like a hyper or a pseudo space drive or a Z space drive, whatever you want to call it, you would be generating that
Oh, yeah.
instead of it being naturally occurring.
and you would probably pass through that in a matter of minutes too, if that were to happen. But in real time, be like hundreds of years.
Think of it.
Hundreds of
Think of
years.
it like
Maybe.
And it's not
Nightcrawler.
time travel technically.
Think of
That's
it
just the amount of
Nightcrawler.
time.
Yeah.
Nightcrawler is a great example of that.
Yeah.
He phases out of our reality. He moves a smaller relative distance in a different, dimension or reality, and then he pops back into ours, like 40 feet away when he moved to.
Or jumper.
Or jumper.
Jumper's
Jumper
a
works.
Fantastic example of that. Yeah.
So yeah, EmDrive so far with the leaked data and the peer-reviewed leaked data, it appears to work. No one really knows why. Yeah,
but it's awesome.
I'm completely okay with us breaking the laws.
Oh, here's an actual I found something on Digital Trends about how it works. Exactly, the EmDrive. Let's see. Let me read this.
At least their theory.
It's called an RF. It's called an RF, which is a resonant cavity thruster. It's one of the several hypothetical machines that's used. They work by having a magnetron push microwave into a closed cone, just like you were explaining,
right?
And then push against the short end of the cone to propel the craft forward. This in contrast to the form of propulsion current spacecraft use, which
the Hall thruster
burn large quantities of fuel to expel a massive amount of energy and mass rocket craft in the air.
Yeah, it's
basically
Hall
like
thruster.
it's just like jumping off the ground, essentially. An often used metaphor for the inefficiency of this is to compare the particles pushing against the enclosure and producing thrust to the act of sitting in a car and pushing a steering wheel to move the car forward. Like
that was pretty much what I said.
What you were talking about. Tests have been done with low energy inputs, resulting in few micronewtons of thrust, like tiny, tiny.
But they're building small scale. That's why, like it. Yeah, like
which
people.
They would have
people
to.
Look at like the energy output and they're like, oh, it's only like 1.2 micronewtons
but you,
per like
you
kilowatt.
multiply
And it's like,
that
no,
times the amount that we
think
need.
of like
Holy crap!
Think of like 1.2 micronewtons per like kilowatt of thrust is amazing.
Let's see,
Especially
like comparable to like a propellant
when you
drive
put, when
is
you
ridiculous.
Put that cone
a
onto
micronewton,
an actual rocket size, you're not going to get micronewtons.
Oh no,
a micronewton is about the force. It's like the weight of a penny.
I know what a
That's how
newton
much
force
it is.
Yeah.
Like,
but
that's
like
gnarly.
whereas like a Hall thruster has like a
it's-
6.6 ratio,
Yes.
this one has a 1.2, which is like
Yeah.
orders of magnitude greater
Yes.
per scale.
Massively.
So that's why people are like, oh man, if this actually works, like we slap those. And it's not just for like it. People were saying that because the first test that people disregarded was done in atmosphere. They didn't put it in a vacuum and it worked.
No, yeah.
And then first there was scientists saying like, oh, it's not going to work. And then it worked in an atmosphere and they're like, oh, well, it wouldn't work in a vacuum because like,
And then they tested it in a vacuum.
Because
and
you
the-
would run out of particles.
well, not just that, but it'd be like, it was like what Steve and I were saying, like pushing up against the wall of a spaceship in a vacuum and expecting it to move. That was the comparable. Because there was nothing for it. They were saying that the atmosphere was what the photons were pushing against.
Gotcha. They were trying to justify Newton's third law.
Yes.
Let's
They're saying
see.
in a vacuum without atmosphere, there would be nothing for the photons to.
You would expel the photons. They would go out into space, and that's just what would happen.
Yeah, they
You
would just go.
You would have a photon
But for some
cannon
reason-
firing photons into space.
Exactly. But for some
The-
reason, even in a vacuum, they're pushing, even though there's nothing to push against.
The EmDrive would be capable of producing 1.2 millinewtons per kilowatt of energy,
which is
insane.
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 It's an insane amount. It's orders of magnitude more powerful than the thrusters that we currently use on spaceships.
It's insane.
And you would have the added bonus of not having to have your spaceship have tons of propellant fuel.
Yeah. I'd be interested to see how much faster they would lift off because I watched the SpaceX launch of their latest Falcon 9 rocket. It took them almost an hour till they finally got into orbit where they deployed the satellite.
Speaking of SpaceX,
SpaceX is really cool.
I
love SpaceX.
I love
yeah.
I love the idea. of
Today was the Falcon 9
privatized-
launch, wasn't it?
No, it was
No,
Thursday.
that was last Thursday.
Was it last Thursday?
Yeah. So a couple days ago.
I love the idea
it
of
was, yeah.
privatized space travel. And Elon Musk recently announced that in 2018, he's going to have commercial flights around the moon.
Around the moon.
He's going to slingshot around it.
Not even our orbit. We're just going to go to the moon.
Yeah, slingshot around
I like it.
Yeah.
Just go big or go home.
Yeah. It was, who was the one who took the first commercial flight?
Oh, I remember
He
hearing about
invented,
this. Paid like 18,000 or whatever. or 180,000.
No, he created the video. What was the big online multiplayer game on computers? The first one that's still around.
Eve?
Oh,
No,
RuneScape?
way before it.
Not RuneScape.
This is gonna kill me.
The first ever
You-
RPG?
You got to help me. The guy that created that game was one of the first commercial passengers into space.
Oh, not a space game.
No, it
That's
was
where I
it
went.
was a
Sorry, that's where I
it
was
was a
thinking
sword
Eve.
and sorcery MMO. It was like before
Oh.
MMO was a word.
Yeah.
That was the game where if you died, you lost all of your stuff.
Yeah, it was all gone.
I cannot believe like one of us. I played this game. I can't believe
I
none of
know
us.
what you're
have-
talking about. It's
Who was
The
the?
only MMO I really did was City of Heroes, and then I played some WoW.
It was before that.
Exactly.
It
That's
was
why
before that.
I know of it, but that's it.
It was like the very first.
Oh god.
It was before MMO was actually a game.
Sword and
That's
Planet. They
Well,
had, and then they had.
Whatever. We can look that up. We'll figure it out. But so this guy, he's the one who booked the first commercial flight.
Mm-hmm. He
2018, he's the first man going around the moon of SpaceX.
No. He did the first. We've already had commercial flights into space.
Oh,
He was
went
the-
to the space station.
Yes.
Gotcha.
You heard that SpaceX is trying to put internet in space?
Mhm.
Yes.
I think that's awesome.
Yeah.
I mean, I haven't been there, but I'm assuming it needs internet.
Well, yeah.
I'm just saying that's awesome.
Okay. I'm just thinking. Think about this. You're at the International Space Station. You are an astronaut on the space station. Probably get fairly bored from time to time. Wouldn't Netflix be awesome?
You don't think they have any kind of internet
I
up
don't
there
know.
at all?
I don't know.
I mean, with all the satellites and everything that are out there, you don't think they have any internet?
But the satellites are relays meant
because
to...
you think that DirecTV works off a satellite as well.
But the
for-
satellites are
like,
relays,
internet
so
and
you're
stuff.
getting a signal bounced from Earth off the satellite back to Earth.
Yeah.
If the satellite's orbit is shallower than the International Space Station, the signal's never going to reach the space station before it gets relayed back to Earth. The satellite has to be beyond the space station.
Yeah, it makes sense.
And I think the space station has one of the deepest orbits of anything we have orbiting us, just for safety reasons. Because we have thousands of satellites. I think India just launched 30 satellites on one rocket.
Was that what it was?
Yeah. India joined the superpowers of space probably last month it was.
Mm.
They launched 30 satellites on one rocket.
So many satellites.
It's insane. No one ever launches more than one or two.
Yeah.
They send up a rocket, just 30 satellites.
The Dragon is scheduled to come back with like 5,000
Yep.
pounds of cargo or something.
They've been doing that for a long time. I remember Dragon was probably about, a year and a half ago when they first tested it, and SpaceX was saying, we want to test this with the International Space Station. And the Space Station said, okay, to test it, we're going to send you some hard copy stuff, files that are important, yes, but if we lose them, it's not catastrophic because we have backups all over the place. We're going to send the hard copies down with your Dragon capsule. And so SpaceX said, great. They launched it. They got it up there completely unmanned. And when it splashed down, everything was all good. It was a major success.
Richard Garriott, who created Ultima.
Ultima!
Yeah, Richard Garriott. He created Ultima Online.
Yep.
He was one of the
I was
first.
sitting there going like, I don't think that has anything to do with what we were talking about.
No, because he went on the first
He was the first
commercial
Yeah,
flight to
non-astronaut.
the International Space
Yeah.
Station. Yeah, he was the first non-astronaut.
that's
to
awesome.
kind of be an astronaut, really, actually.
Paid money to remember because it was supposed to be him and Lance Bass, and
Oh,
they
yeah.
weren't able to launch because the American capsule was faulty. So Lance Bass dropped out, and they used the Soyuz Russian.
The cosmonauts.
Yeah, the capsule that doesn't land so much as it falls back into atmosphere, and hopefully
That's so
It's the
crazy.
water.
hopefully the parachutes deploy and it hits the water.
Yeah.
Yeah.
Because even if the parachutes deploy, it needs to hit the water.
It's crazy to me that we've come to advancements to like Outlaw Star to where you can take rockets into space and then just land them right back down and
Oh, yeah.
dock them. That's so cool.
Yeah, that's SpaceX. That was amazing.
So crazy. They did it a few times, didn't they?
Yeah.
They landed one in the ocean, didn't they?
On the
Yeah.
platform in the
That's
ocean.
so insane.
Oh yeah, that's amazing.
insane.
Yeah.
That's what happens when you privatize space travel.
Yeah.
I mean, I think you said off camera Kennedy was the one who originally
Absolutely
Star Wars.
brilliant move.
conceptualized.
I mean,
privatizing space
we
travel.
all looked at
Yeah.
it. We've been looking at space for thousands of years.
Which president had the Death Star idea? Was that
He had the Star Wars. That was
yeah?
Ronald Reagan came up with
Ronald
the Star
Reagan,
Wars
yeah.
plan, but that was a missile defense system.
Yeah,
Yes.
that's what
Basically-
I was talking about. Who was
oh,
it that
okay.
had it?
It was Star
called
Wars.
Was it called Star Wars?
It was Star
I thought it
Wars.
was Death Star for some
No,
reason.
no, it was Star Wars.
Yeah,
The
Which-
code name was Star Wars, but the idea behind it was that if you have a missile coming at America, we're going to shoot another missile at it and intercept it mid-flight
yeah,
and blow it up
and
in
that's
air.
what
Right.
brought about missile defense system, right? Essentially,
Yeah,
well, one of them.
an active missile defense system,
Which
but
we
like,
have.
And it
well,
also
the
brought
mathematics involved in like
It's
a missile that's going, thousands of miles an hour. I got to like launch it from here at this exact time at this exact
Angle.
declination and inclination. Yeah. For it to like connect at point X is like,
that's so crazy,
oh yeah.
And
but it's possible.
it also
That's
brought
the crazy
about
thing. They have figured
missile
it out.
command.
Dude.
Missile command.
I always get wrecked.
Yeah, I do too.
Missile command.
But no,
It
Kennedy,
gets to a point where I'm just like, fire everything.
I want to say Kennedy was probably one of the greatest things that he could have done. We've been looking at space for thousands upon thousands of years. I'm sure NASA had been looking at it going,
Yeah, it's always been there. I
how
always look
could
up.
we-
It's always
but
black.
We've always wanted to go there. Man is always, it's the Icarus.
Really, Brian?
We've always
You had to wave at
wanted
that.
to go to space.
We get it, Brian.
It is the
You're
final
black.
frontier.
It really is.
Like without getting to like
Where no man has gone
Space.
before.
We live
the
in
final frontier.
But it really is.
He winked at me.
No man had gone there before. And Kennedy said, I want a man on the moon in 10 years. So, private companies, here's, do what you need to do, but I want a man on the moon in 10 years. I'll fund it. Make it happen.
And we were tapping so many different people in order to fund that program. Like there was such, I think the movie that just came out about the black women who were like the behind the scenes mathematicians.
yeah.
What was the name of that movie? Hidden Figures. That was the name of the movie. Hidden Figures. About, the secret. I asked you because you're behind a computer, not because you're black.
No, I was gonna look it up. I was gonna say I own the movie, so I wasn't gonna.
Oh, okay. I only like out of my periphery saw the hand signals and I thought, okay, never mind. Yeah. All right. So it was about, I don't know. Have you seen the movie?
Yes.
It's really good. It was about the secret colored team of women who did all the
It was
mathematics.
fantastic.
That's what they were called.
It was incredible.
Yeah, it was
It
a
was
really
really
great,
good.
It was a really great movie. Taraji was great. Kevin Costner, who's usually like
Hit or
hot
miss.
and cold. Yeah, he'll do a really good movie,
Wait,
and then
so
he'll
he's
do like
sometimes on fire and sometimes ultra cool.
He's on fire.
well done,
Thank you.
well done on Ultra Cool.
Um,
that was Matt's phone.
Yeah, it was. I couldn't see the timer, so I was trying to tell Brian to tap the screen. I sent it in the group text, so it turned it on.
Fantastic.
That
Did you
was
ever see
clever.
October Sky?
Yes.
Fantastic.
Oh.
Yeah,
Because
Yes.
that movie gave me such an appreciation for just like rockets in
That
general.
movie got
It
me
was
into
so good.
model rockets.
So good.
I still have a bunch in my my closet.
Who was the guy that played the main character? It was
Tobey Maguire.
Tobey
Yeah.
Maguire. Yeah. So good.
Before he went all stupid with Spider-Man.
Fair.
Thought-
I'm sorry. There was one good Spider-Man movie out of all three of those.
Nobody's.
I could have sworn from our blood pact that I don't remember making. That was another part of it. We weren't going to mention that.
He brought it up.
I-
He brought up Tobey Maguire. How
But
dare you?
You brought up the other part.
I'm sorry. No, it's Jake Gyllenhaal.
Oh, is it?
Yes.
Really? Is Tobey
I
Maguire
thought it was
in
Jake.
that movie?
I thought it was Jake Gyllenhaal, but I don't want to say it. It's
Wait,
Jake
is Tobey
Gyllenhaal.
Maguire in that movie?
October Sky?
We brought it up for
He
nothing.
might be.
I feel like he is.
Let's look at the internet.
IMDb,
Internet.
come save us.
So
I have
with
the power of the internet
with-
right in my hands. Right?
with SpaceX,
And now you can have it in space because
Hey,
SpaceX, is
SpaceX is
going
going
to
internet space. Full circle.
with SpaceX, I think the
like
main what Elon Musk has been saying for the longest time is that he wants to go to Mars. He wants to colonize Mars.
Oh,
that is the express mission of like the SpaceX program.
He can do it.
He can.
He was not an
The
October
man is a
Sky.
genius.
He was not an October Sky, but Chris Cooper was, and like Chris
Okay.
Owen.
I'm thinking about something else then.
Yeah.
We just wanted to talk about how cruddy that Spider-Man was.
Yeah.
Rant over.
Spider-Man
Let's keep moving on.
Spider-Man sucks. But yeah, so
What are we talking about?
we're talking about Mars.
Oh, Mars is neat. We're gonna send people
what
there.
What are we gonna?
Hopefully.
We're gonna send.
We
people
already sent people there.
Didn't
there. I feel it.
what?
Go ahead.
Here we go. Let me hear it.
Oh, you want the joke? Because they're serious. We have rovers on Mars.
That's not a
That's
person.
not a person.
People.
Okay,
People
fine.
to Mars.
Well, we sent Matt Damon to Mars. All right.
That's where you went.
Yeah, that's where I was going.
I had a feeling it was
Wait,
gonna
wait.
be.
Who did we send to Mars?
Matt Damon.
Nope.
Matt Damon.
There we go. That's who we sent to Mars.
Yeah.
I love that he has a great sense of humor about that. Did you ever see
Matt Damon?
Oh yeah.
Oh, yeah.
No, Matt Damon.
Yeah. He actually does that.
Yeah.
And like
knows it's a joke.
after that movie came out,
Mm.
he was doing, I forget what movie came out like right after Team America came out, but for like his whole publicity, thing that they do for movies, the junkets, the press junkets that they do
Yeah.
for movies.
Yeah.
He was touring at the time when Team America came out, and so after he saw the movie, he's like, they would like go around, the panel and be like, "Oh, I'm blah blah blah, and played this in the movie," and he'd be like, "I'm Matt Damon," like for the entire press junket. And the producers and directors and studio executives are like, "Please stop doing that." He's like, "No, it's funny."
You got to be able to make fun of yourself.
Yeah. So The Martian, Matt Damon.
Matt Damon.
Matt Damon. Yeah, I feel like that's the eventuality. That's his express goal.
Okay, here's my question.
He
for you.
hasn't.
I have a question. Serious question.
Okay.
Based on the technology that we have now
Mhm.
and what you see us doing, and the stuff that Elon Musk has come out with, like that, basically the air tube from LA to San Francisco that would take like 28 minutes. Based on all of that,
I want that.
That's pretty cool.
that
I
is
want
amazing.
That
Yeah.
the first time I read about that, it reminded me of Futurama.
Yes.
Oh yeah.
Like
Yeah.
the tubes just everywhere.
It's like the things
off
at the
it
bank.
goes.
It's like
Yeah,
the
it's
suction
like
tubes
the
at
old,
bank.
the old school
That's
suction
exactly
tubes.
what it's
I
based
love
off
it.
of. But like, so considering all of that, how long do you think before we're there?
He says less than 10 years.
See, I think it's going to be about 10.
He says
for that train.
no,
No,
for
to
to
be
get to
on
Mars.
Mars.
Oh, I
Elon
was gonna
Musk
say,
is
what
saying
did
10
what
years.
did NASA say about that? Because they've already got people all signed up and everything.
Well,
don't they?
it's two different things though.
They were.
You know what
I
I mean?
think they were testing people
NASA
for
is
deep
Well,
government
space.
funded.
yeah.
They're not the same teams.
No.
So Elon Musk is saying SpaceX, we're going to put people on Mars 10 years.
I think it's possible
I think you can
considering
do
the amount of like
I don't
advancement.
think you can do it in less.
I
think
no,
it's
no,
going to be
10 years at least. But how much he's advanced, like pushed
I
the
think
advancement of like just space
by
exploration
the year
already is
2030,
insane. I think
we are
10
going to
years
have
is
a
perfect.
sustainable colony on Mars
And when?
by 2030.
So what?
Do you imagine it being
That's 13 years from now.
yeah, you really
terraformed
think that we'll
or
have a
domed?
full scale?
I'm thinking more domed. I don't think we have the ability to terraform yet. And I could be terribly wrong.
Well, there's a lot of theories on how to terraform a planet.
Here's a question then.
Okay.
Because and this is something that might be way off, but so you're talking about colonization on Mars in domes, right?
prefabs.
And we're
Let's
also,
just call it prefabs.
we're talking about
Well, we have that.
we've been talking about the EmDrive. We've been talking about all these stuff with SpaceX and everything. We have the International Space Station, so it's proven that we can be inhabitable within space. Just space itself, we can inhabit. How long do you think before we do like a ring, like a Halo ring, where like we just have our own thing that we build and we colonize on it just in space?
So
Is that
So,
something
like,
you
there's
think?
basically
there's a lot of
a-
problems with that.
There's a ton, but
a
I'm just
space
saying
station so big that it's like
it's like a colonization ship.
okay, the Citadel from Mass Effect.
Yeah,
It's
like that.
actually a artificial structure, but really it's housing hundreds of thousands of people.
Yeah.
That's a long
Not
ways off.
until we create like an artificial
Gravity system.
Gravity system.
Yeah,
Okay.
because the
Because-
people on the International Space Station are in zero G.
Yeah.
And you can't be in 0G for
Do you
too
think that
long.
that's something that
negatively
it's like
affects?
it's like quantifiable, is to like create something that can replicate like gravity?
I think the
Do you
closest
think
we
that's
could
something
come
that
to,
we could do without like Could you imagine like if it was just a little too heavy?
Well, but now think about this.
You would just
This
goo,
is-
dude.
this
Like
is
you would just turn it on and turn to goo.
This is just spitballing here, but if you had, and it would be incredibly expensive. I don't think it's feasible. It would be from a physics standpoint, but nothing else. If everything that you wore was like magnetized, just little bits flex, and then you had the floor completely magnetized,
Mm.
and it was all measured out so that what you wore would weigh down. It would just function like normal Earth's gravity. I could see it working. But then I don't know how that would work. Like walls wouldn't have to be, and it would.
Feel like you would walk around all day with goggles on and you would never take off those.
Do you think
goggles.
like in zero gravity there's an amount?
Because
particles
Wait,
in your
are
eye
you
would
saying
go blind?
Are you saying that in zero gravity there's an amount of weight that we can have that would weigh us down?
Yeah, you spin it.
So it would be something that would be constantly spinning to keep us down.
No. The theory I just came up with was more like you had a generator running, and your floor is magnetic.
Oh,
And then everything
okay.
you wear, and of course, he brings up a
It
good
just-
point. You'd have to wear
I for
goggles
some
because
reason
there'd be
thought that
particles
like you're like,
everywhere.
oh, we have this huge massive thing out there, and everyone just weighs a lot. Hopefully they stay down.
Well, no,
I'm
think-
like,
think
no,
of,
we can't. We
think
can't
of,
do that.
Think of 2001: A Space Odyssey.
Yeah.
The way that they created an artificial gravity was they had a spin on the ring.
Right. Yeah. I understand. Like, I understand how that works.
Mm-hmm.
Like, it's kind of like the same thing where it's like if you have like think of like a dumbbell, or like a curling bar that has weights on the ends. If you take the weights off one end and you try to lift it, you can't lift it. But if you can manage to get the RPMs, like spin one side, like one weight really, really fast, it's like featherweight. You can lift it above your head because it's all, so I understand how that would work then with the
because it's
motion working.
rotating so fast that the weight isn't hanging on the dumbbell.
Right.
It's
creating
spinning, and there's actually almost for the most part a very thin layer of air between the weight and
I think
the bar.
you're talking about centrifugal force.
Yes.
Yes.
It's actually centrifugal force. It's when you have a bucket of water and you spin the bucket of water around your head like in a circle
And
with
the
your
water
arm,
stays in.
and the water stays in.
Yeah.
It's
I was gonna say
they're
it's
similar, but they're different.
No, I was gonna say like there's that where like because essentially if you do that it goes up. You can't force it down.
Yeah.
Like so I was gonna say it's the opposite of that.
Yeah.
Yeah.
It'd be spinning backwards essentially
Mm-hmm.
because I think if you spin backwards it's the same thing. It goes the other way.
Superman set time back, right?
All right, and with that we
Oh,
need to wrap up.
I hate you so much.
And we're gonna wrap up now.
Because you made a Superman joke. Oh, well, if the Earth spun backwards, then time goes backwards. That was the logic for Christopher Reeve's Superman. Like, I'm just going to go around backwards. It's not going to destroy, like, Los Angeles, Tokyo, every coastal city on the planet by throwing off the tides. It's going to make time go backwards.
obviously.
Why did anyone think about that? I don't even know.
Didn't he go back in
I
time
don't
to
even
war
No,
Bruce?
the Flash did not. That is not how the Flash went back in time. That is not how the Flash went back in time.
Look what you did.
I know.
Look what you
I have
did.
so much
Brian,
fun
look
with
what you did. You did this to us.
The Flash tapped
Oh,
into.
Blake.
Now you upset him.
The Flash
Now you
tapped
upset him.
into the Speed Force
We had a good podcast and then you
and
started
moved
talking.
outside of his relative dimension
Wait.
to go back in time.
So what you're telling me is the Flash did what our EmDrive does, supposedly, in theory. Stepped out of a dimension.
It's not that the EmDrive is
Bruce
moving
Wayne, sir.
out of the
But
dimension.
the photons it forces out are
Are pushing
against it.
Yes.
So you could say the Flash functions like that EmDrive theory. Similar to.
The difference is that the Flash, Barry Allen or whichever Flash you want to talk
Yeah.
about, they don't inherently have the ability to run fast. That's not how the Flash is. The Flash taps into the cosmic speed force, and that's how he moves. And that's why he's not turned into jelly
Right.
when he runs fast enough.
Did we talk about that with the EmDrive? The amount of how much goo we would be turned into from the amount of like just traveling from
Oh,
0
okay.
to warp speed.
Okay, well here's a cool
I don't think we talked about that.
bringing it back to science fiction. There's a
From 0
show.
to light speed, just goo.
There's a show. I don't know if
Instant
you've
goo.
seen it, and they have like 6 or 7 books out. It's by James S.A. Corey, but it's actually 2 guys.
What are you talking about right now?
It's called The Expanse.
Oh,
the,
yeah.
the novel series.
yeah.
Have
Yeah,
you
yeah,
watched
yeah.
the show?
Isn't that
Yeah.
on Netflix?
It is on Netflix.
Yeah.
I haven't actually watched
The
it. It's on my
watch
list.
it. It's
on
amazing.
my list.
It's a
You
great
should-
show.
it's
The books are
fantastic.
fantastic.
Yeah. Yeah, I know exactly
but
what you're talking
the
about.
way they explain that, because they're moving at such a high G-force, is that they have these liquid cushion chairs that mold to your body. So
Yeah,
while you're
We were
thrust
talking
back,
about this, yeah.
but they also have these arms. So like when they're flying, like the pilot is like this because of the G-forces, and he has all of his controls right here. So he just exerts minimum amounts with his
of
fingers.
energy with it, yeah.
But the other thing is that they're strapped in, and I just hit my mic. They're strapped in, and they have intravenous injections. So while they're going that fast, because you would pass out from the G-forces,
Right.
they're pumping them full of like speed and adrenaline
Yeah.
to like get them to stay awake so they can pilot.
That's so crazy.
So I think it would probably be that drugs.
Something similar.
Okay,
Lots of drugs.
Okay,
Drugs.
Quick jump. Would there be an effect like in Spaceballs
Good
where
joke, by the
when
way.
you slow down, quick jump,
Did you catch it?
like that, quick
Yeah.
jump, you would lurch forward.
Well, they're strapped in,
They're strapped in.
But
so you would push against it. Yeah.
from that speed,
Well,
you'd
okay,
have to go
and they
slow.
talk about
You
that
can't
because
just
It had,
stop.
because
it
they
had
have
to be gradual.
You
well, no,
cannot
because
just
they
stop.
they have space combat, and they talk about the movements. Because say you're going at X amount of speed, but then you do a hard turn, the G forces are exponential
Yeah.
when you're
Yes.
pushing you back.
Yeah.
And same thing when you're stopping. Like so,
So
when
the
they're
chair is built with the water, the straps may not be. You can't just stop.
well, it's like it's not just like a chair. Like you're sunk into it.
Right, but
so
it's
this
built
movement
to
is
absorb,
also-
whereas
yeah.
this is limited on the absorption.
Yeah, so when they're coming, when like say they're moving from like point A to point B, and it's like a long distance away, they start slowing down
Pretty quick.
well before they
Yes.
get there.
Yes.
And so that's why space combat is so interesting, like to read about it. And they just started having it in the show where you see like
Yeah.
the relative movements. I think like one of my favorite shows that had space combat was
Outlaws don't. No, I'm just kidding.
no live
Crap,
action
Elite spaceship battles.
was Battlestar Galactica. Because a lot of shows and movies up until then had, you know, your fighter ships moving as if they were in atmosphere.
Yes.
Yes.
Like Star Wars does this. This is a big problem with Star Wars, is that when they're doing the Death Star trench run or when they're fighting in space battles, the ships are flying as if they're in atmosphere. So they're making turns and everything as if they're under atmospheric pressure and gravitational pull.
Yeah.
When that's not actually how they would move. When say you're flying in atmosphere and you're going like this and you need to go this direction, you make a gradual turn, right? Space, it's a vacuum. So Battlestar Galactica was
There's
like
no
one of the
reason for,
first
like-
shows to like show them just flip over on a dime.
Yeah.
And the pilots were trained to like be able to like
Withstand.
kind of
There's
rock,
also like
rock
you
with
know
that
how
G.
like in a lot of those like sci-fi films and stuff, they always make the ships look so like
Aerodynamic.
aerodynamic.
You don't have
You
to.
could make them like a box,
The
and they would
board.
have just
The
as
cube.
much, just as much like maneuverability as something that was built.
you
that
don't
way.
go
I feel
into
like-
atmosphere.
Yeah, once you go into atmosphere,
If you land
you're
on a
screwed.
planet,
the
yeah.
thing,
You're not
the
getting
thing
back
about
off.
like if we're gonna keep doing Star Wars, is that the X-wings were made to be to land and take off in atmosphere.
Yeah, they're the best ones.
So,
ships
but
ever
the same
made.
thing with the Vipers in Battlestar Galactica. That's why they have that sleek aerodynamic design, so they can make
But
landings in
capital
atmosphere.
ships don't need to.
Yeah, the actual battle stars were just a long like cylinder.
But if you
basically.
look if you look at the Star Destroyers, they're relatively
they're hunks of
conical.
cheese.
Yeah,
Yeah, they're a wedge of cheese.
yeah, they're actually kind of slightly
Yeah.
aerodynamic. But anyway, we got way off from our wrap.
no, we stayed on
techni-
point.
Technically, actually, the Star Destroyers can land in atmosphere.
Yes.
they're aerodynamic is what
Yeah.
I'm saying. But
Oh, okay.
like you don't need to when you're a capital ship staying in space.
I think the other thing is that if you're making a fighter ship, you want it to be sleek just for targeting reasons.
Yes.
Like a big ball, I feel would be easier to target than something that was more sleek and aerodynamic looking.
Agreed.
So
Yeah.
When your S foils are locked open, you can miss between them.
sure, yeah.
There you go, Matt. You got
All
it.
right.
Just saying.
All right, we need to wrap up.
God.
Thank you for listening to our ranting and raving about science.
Space.
Science is awesome.
This wasn't a
Space
rant
is
at all.
awesome.
This was actually like highly informational. I had my mind blown.
You did, which was awesome to see.
That was fun.
It was a lot of fun.
All right.
You can find us on iTunes and Podbean and Google Play. The links will be down here, down below. Make sure that they're bit.ly links, so put them in exactly as they appear, or they won't work. You can find us on Twitter, Facebook, just Instagram. Everything is
all the social needs.
at Likable Geeks. Those social medias will be over here as well. You can find me on Twitter at that Stephen Brown.
You can find me, usually not on Twitter, at Believe the Weave.
You can find me ranting and raving at Twitter at Stu_no last name.
And you can find our producer, Brian, on Twitter at the Bro Chacho. All the underscores. Just search Super Token. He'll pop up.
It'll be here.
And I think the final thing is that if you guys like us, we do have a Patreon.
We do have a Patreon.
We do.
Patreon.com/LikableGeeks. You can become a patron for us, and you can hear super secret podcasts and get dice and shirts and all sorts of fun things in relation to our podcast.
Early testing of our game, which
Yes.
is going into alpha testing.
Yeah, we're going to start actually doing that.
In April, we are still doing We're going to be doing a rather large stream for International Tabletop Day, where we're going to play some board games. Where we're going to play like Elder Sign and
Elder
a few other
Sign,
things.
Dead
Redneck
of
Life.
Winter.
Redneck Life. I'll see what else I've got.
Dead of Winter.
Yeah,
Dead of Winter. The
The game
hardest
of a million
boys.
pieces.
The hardest boys may be joining us. We're going to play the Dark Souls game.
Sounds like
Awesome.
fun.
It's going to be awesome.
We can also, if
Well, I'll
hardest
stand
guys,
point. You don't do that.
You don't do that.
Yeah, hardest guys, we can throw. We might actually be at the point where we can have other people
Bring them in on the alpha?
Yeah.
Sure.
Yep. We might be because we're shooting to do the alpha test for your guys' game on that
on
day, right?
International Tabletop Day.
Well,
yeah.
I mean, an alpha test.
Hopefully.
I'd
gonna
like to
be-
get one before that. I'm going to have it
Yeah,
ready this
we're
week.
gonna do some stuff.
I'm going to have some alpha ready this week.
Yeah, we're gonna be streaming that on Twitch. You can find us on Twitch, twitch.tv/LikableGeeks for that. So follow us and make sure you enable notifications so you know that when we are going live for that.
And
So-
feel free to give us some constructive criticism.
no,
Leave
don't
a
do
comment.
that. Don't do that.
Yeah, tell us how much we suck.
Yeah.
Tell us what you think.
We always like feedback. We
Yeah.
like hearing from you guys. So, well, thank you guys for listening to us and watching on YouTube for talking about science and other fun things in relation to science.
Science.
Fiction. It's a
How
good
does
time.
it work?
We still don't know.
Nobody knows. Question mark.
Science is hard.
We thought we knew, and then we broke it.
We don't. All right.
So, thanks, guys.
Thanks,
We'll
guys.
see you guys next week.
Bye.
Bye.